In this video, I'm going to talk about artificial intelligence, and toward the end of the video, I'll tell some really important stuff that I've been learning and what I think about the future of AI. So I've been doing AI or focusing on it 40 hours a week for the past 7 weeks. And here's some stuff that I've learned, some simple things, and then I'll get up toward the end of the video to what I think the future of AI will be like based on that study and my previous on and off 6 or 7 years of AI study. So artificial intelligence, it's mainly neural networks that are used right now. And neural networks, they consist of things called multi-layer perceptron, or they're called multi-layer perceptrons. This is sort of part of the history of AI. I believe it was the 1920s, there were some people that came up with things called the perceptron, which was partly made to imitate the way the human brain works. And they got in a paper they wrote, they mentioned 2 articles that they got some of the stuff from. And one of them was from a person named Bertrand, I think it was Bertrand Russell. And the other one's, I don't remember who the other one was. But that was sort of where it began. And then as computers started advancing, people wanted them to do more stuff. And fast forward to Geoffrey Hinton in, I believe it was 1986, he created the backpropagation algorithm, which is used in artificial intelligence to this day. And he created something that was a really scaled down version similarity to ChatGPT in 1986. And fast forward to 1998, a guy named Yann LeCun, who's now the head of Facebook's artificial intelligence, he created something to do with convolutions, which looks at a picture, but it looks at patches at a time. And it creates something called translation invariance, where if you have, just say, a picture of a cat, and the cat is in a different spot in the picture, if you didn't have this convolutional neural network, then it may not recognize it as well, because a cat over here to a computer is way different than a cat that's over here. But if it looks at stuff in these patches, then it can just recognize this as the corner of an ear of a cat, and whether it's over here or over here. So that's called translation invariance. Because in geometry, there's at least 4 types of transformations are called geometric transformations. There's the translation, which just means move it around, like the cat picture. And then you have the rotation, which means turn it about some specific point. There's reflection, which says, just say if you're reflecting across the y-axis, then however many points in the x direction this is, make that point on the line negative from what it originally was. Just say if it was positive 5, make that point negative 5. And if this one was positive 3, make it negative 3. And do that for all the points. And then that mirrors or reflects across the y-axis. So that would be the reflection. And then the 4th one is dilation. Like pupils dilate, and they get bigger or smaller. And what happens is, just say they get bigger. You have a circle, and you want the circle bigger. That's called dilating. And if you have a rectangle, and you want that rectangle to get bigger, you keep each of the 4 angles at 90 degrees, but you make it bigger. In other words, that dilates it. So those are in geometry for transformations, but that translation just means move it around. So that's partly what the translation invariance talks about with the convolutions, is where if you move the cat picture from here to here, or stop sign picture from here to here, or anything like that, then it doesn't make as big of a difference, because you're using those patches to recognize the corners of the cat ear or the stop sign, instead of where it is in relation to everything else in the picture. So that's in 1998, Yann LeCun did that. He'd built on top of a paper written by Hubel and Wiesel, where they attached an electrode to a neuron or some neurons in a cat's brain back then, and they put stuff in front of the cat, and they recognized that certain neurons fired when it would see edges move, and different neurons would fire with different things. So they realized that with images, like the brain, it processes in sections and pieces those together. Some parts of the brain, like brain cells, might process things like a diagonal edge in certain locations of the field of view, like when you're looking at something over here versus over here, that same edge, diagonal edge. And then others might recognize this edge and this edge as different, and this and this and so on. And certain ones might recognize colors and so on. And then the brain pieces all that together and says, this is a picture of a whatever's in front of it. So like a picture of a stop sign or whatever the image recognition's going for. So that was in 1998 that Yann LeCun did the convolutions. And fast forward to 2006, Geoffrey Hinton, he's real popular, or he's pretty popular now in AI. That's the same guy that in 1986 built something kind of similar to ChatGPT and came up with the backpropagation that's still used to train neural nets. So in 2006, he made convolutional neural nets where he combined the neural networks with backpropagation and the convolutions that Yann LeCun and them figured out. So when he did that, it made it where neural nets can recognize images way better. And then you fast forward to 2012, where the things called AlexNet was developed, and it's one of the big liftoffs of AI. One of the reasons it started becoming so popular is because it did so well. And it was called AlexNet because it was created by 3 people. One of them was, again, Geoffrey Hinton, and another one was Ilya Sutskever, who I'll mention later, and another one was Alex Krizhevsky. And so it's called AlexNet, like Alex network or neural net. And so what it did was it made really deep with lots of neurons, neural network using convolutions to recognize images. And Fei-Fei Li had headed the group that gathered together things called ImageNet, or as images for a competition called ImageNet. And so in 2012, the AlexNet, it way outperformed the stuff from the previous year. And it's partly because of processing improvements with graphics cards, and because there's more data available, and because they made really deep neural networks with lots of perceptrons in them. And so they made that, and in around, I believe it was 2015 or somewhere around there, 2015 or 17, the company OpenAI was started by 3 people. It was Elon and 2 others, and its purpose was to be open so that the public could see it. And so Elon recruited Ilya Sutskever, who I mentioned earlier, as part of that AlexNet group with Geoffrey Hinton and Alex Krizhevsky. And so Elon, a guy named Andrej Karpathy, who I'll mention later also, them and I believe it was Greg Brockman, and they and maybe Sam Altman at this time started OpenAI. And eventually Musk left because it wasn't as open as he wanted it to be. And Sam Altman was CEO. And so they built out ChatGPT. And that's when AI started becoming extremely popular. And eventually, Ilya Sutskever left OpenAI, and now he's started a company for super artificial intelligence to make it safe. And Andrej Karpathy, he worked at Tesla for a while, and he's one of the people who brought self-driving to Tesla. When they first started, I believe he said there was 2 people working there, and they just had some computers by their feet, and that was their AI department, basically, for self-driving. And so he headed the team and over a 5-year period, I think, and made it to be super big. And he eventually left there, and now he teaches videos on how to write AI from scratch. And so you can look him up on YouTube if you're interested. But he has like 10 plus hours of videos of just detailed writing it from scratch, all the way from the fundamentals math upwards. And so that's part of the history of AI. And what I think that the future of AI will be. It starts out with fundamental laws of nature. And the most fundamental that I'm aware of is the lowest energy state. There are 4 fundamental forces in the universe. There's gravity, electromagnetism, and the strong and weak nuclear force. 4 fundamental physical forces. All the other forces are parts of those, other known forces. So gravity, people are aware of. Electromagnetism is what makes electricity, magnetic things, and what holds atoms together, and what holds atoms and molecules together. And that's why we don't fall through the earth to the center of it, because the atoms of the ground are held together. And that's what holds us together, is electromagnetic force. And you could say if lowest energy state is the fundamental part, then where does energy come from? It comes from competing forces trying to get to their lowest energy state. So you have electromagnetism and gravity. The other 2 forces I mentioned previously are to do with, subatomic things. So people are not as familiar with interacting with those directly. But gravity and electromagnetism as examples of lowest energy forces aiming on getting to their lowest energy state, creating energy, is hypothetically, say, if I have a rope tied to a generator, to generate electricity or energy, you spin the generator. So if I have a rope that's wound up around the generator and it goes over a wheelie or a wheel that's elevated, and then you put a weight on that, a heavy weight, and you tie that rope to that heavy weight and you let go of it, it converts this gravitational potential energy, the energy from gravity that hasn't been used, it converts that by pulling that wheelie down and spinning that motor. It converts it to electromagnetic energy. And so it's converting gravity energy to electric energy. Gravity is trying to get the weight to go down toward the center. Gravity is trying to get the weight to go toward the center of mass of the earth. And electromagnetism is trying to, keep stuff positive and negative, even in level. But this gravity trying to get to its lowest energy state is causing the wheel to turn, or the axle to turn, which in turn which also causes the magnet inside the motor to turn, or the generator. And that induces a magnetic field by pushing electrons around through the copper wire. And that's generating electricity. So two fundamental forces, their fundamental components, or what their aim, I guess I should say, is to get to their lowest energy state. So they compete with one another and they create energy by doing so. So neural networks, they aim on getting to the foundation, or getting to what's called the lowest loss. It's where you calculate how far off the neural network is from the correct answer when its first guess is the correct answer. It's like if you're teaching somebody, just say English or something like that, and you hold the flashcard with the number 1, and you say, "What is this?" They might just randomly say blah, just something random. And then you say, "No, it's a 1." And then they may say something that sounds a little bit more like 1. They might say 1. You might say, "That's close, but it's 1." And they may then, get closer and say 1. Be like, "Yeah, that's even better." So what happens is they have input, the photons bouncing off the image of the 1 into their eyes, and the rods and cones, or the parts in the eyes, process those wavelengths of photons, and it goes to the optic nerves toward the primary visual cortex in the back of the brain, and that processes that, and then you say something as the output, and it basically the person would guess to begin with, and then they would hear how far off they are. If they said blah, but the answer is 1, then the brain gets feedback and hears the difference between them. So it makes adjustments and tries again, and it should be closer the next time. And then, but when they try it again, you hear the correct answer and see how far off it is, and then it makes adjustments and tries again and gets closer and closer. So that's the fundamentals of how neural nets work. And you could think of it as the lowest energy state. They're trying to get to their lowest loss state. And it's doing a whole bunch of stuff to do that, but that's its main goal. And that's how the fundamentals of neural nets work. So now talking about the future of artificial intelligence, how that relates is, since the brain wants to do stuff to its lowest energy state, it doesn't like wasting energy in general. I think that the future of AI is that autonomous vehicles will become more popular, whether people think it's good or not. It's debated. Some people think it's good, some people think it's not, but I think they'll become more popular, at least with some people, and that they'll improve, that they'll get better over time. I say time, but stuff doesn't improve unless you make it improve. So it depends on how much effort people put into it. And so everybody wants, safe vehicles and so on. So if it ends up being way safer than humans, then I think the adoption of it will increase. Also, humanoid robots, I think those will increase as well, partly because they can do jobs that humans don't want to do. Like if jobs are unsafe, or if they're annoying, basically, people can buy their own robot to do the jobs for them, depending on what types of job it is, to an extent. But people do want to work in general because it, in a way, gives meaning to life. Like if I'm doing something and improving things, then that's helping people, and it's helping me figure out how to do that better. So I think that humanoid robots will increase, and probably mostly in factories, and that jobs will shift some toward other areas. Like in a way, like some factories have robotic automation already, and it's kind of been gradual throughout the years. It's increased. So just like when the horse and carriage were around, it was a transition to vehicles, but it also created more opportunities, because then there were, the people that were driving the horse and carriage, and the people that cleaned up after the horses and ones that fed them and so on, they eventually, some of them probably became mechanics to work on cars. So it created more opportunities, and it improved total efficiency in the overall, in the big picture. Are there negatives? Yes, with any kind of technologies in general, there's negatives to it, but there's also positives. And so it's good to weigh out the detailed individual cost and benefits and the overall big picture societal costs and benefits. And another thing that I think the future will be like is deliveries for, say, like ordering stuff on Amazon and so on. I think possibly drone deliveries may increase, and because people get products faster. And possibly another thing I was thinking of is that robots, like small transportation robots that are made just for carrying products to people, may become somewhat prevalent in cities, and like delivery autonomous vehicles, basically. And so that goes to the warehouse, just say Amazon, and they load the items onto there, and it just goes on the road like a vehicle and goes to different houses and delivers them, sort of like a UPS truck. But it would be quite a bit faster because you can go directly from the warehouse to those places that orders specifically for those products, or like the Amazon products. So I think that's one direction that it would go toward as well. And also about AI safety, I think it would be good to implement controls for AI such that, just say if AI becomes this huge machine, what you want it to do is have the ability to do things that help humanity, but be able to make it so that it can make sure it's going in the right direction. One analogy I think of is driving like a huge tractor or a giant land excavator. It's way more powerful than humans physically, but humans can steer it and make it do stuff that's useful for people. So I think it would be wise to implement specifically AI algorithms that ensure that humans have the ability to steer it in the correct direction to make sure it's beneficial for everyone. And another analogy to that real quick is that a ship, a giant cargo ship, it may have a big rudder, but in order to turn the ship, it would be really difficult to turn the handle and turn this tens of thousands or millions of pounds rudder. So what happens is there's a small rudder on that big rudder called a trim tab. And what happens is you turn that small rudder because it's way easier to turn. But when that happens, that causes the big rudder to turn. And that in turn causes the ship to turn. So it would be important to have sort of a trim tab for AI so that it can be guided in the right direction to help humanity. And so those are some things that I think for the future, and it would be good for people to learn in general and understand at least the big picture of how AI works, so that they can, help ensure that it's done useful for humanity and safe, and that it benefits everyone. And so that's some of the predictions of future of AI. And I think that if it's done right, it can help humanity a lot. So, and if it's open source, so everybody can see it and make sure there's not errors in it, or make sure there's stuff not written wrong in it, and so on. So I think if that's done, that could increase the probabilities of making humanity have a bright future, and that could help cure diseases and solve world hunger and just make people's lives better. So that's my hope, and thank you for listening. And if you have any comments, just let me know, and be sure and click like and subscribe, and have a great day. Thank you.